Hi, welcome to TechRanch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation, circular linked list. So today we are presenting you a live demonstration and implementation of circular linked list using Java. So in this session, we are going to see how we can implement and perform some operations of insertion and deletion in a circular linked list with all complete and detailed information about application, requirement, and advantages and disadvantages. Now, before we get into the actual implementation of circular linked list, let's see what is actually a circular linked list. And before that, let's just revise what is we have learned about a linked list in the previous session. Linked list is a type of a data structure where a list is implemented by each item having a link to the next item. This type of data structure is maintained by node, and this node divided into two parts. One is called a reference and another part is called data. So as you can see, the 10 is your data and this is link or called a reference. Head points to the first node and that shows the start of the list, and the last node points to null when the pointer or the reference was mentioned as null. That means the end of the list. Now let's see what is actually a circular linked list and how it is different from the linear linked list. A single linear linked list has every node pointing to its next node in the sequence and last node pointing to null. So as you can see, it starts from the head. The head is a reference which is pointing to the node data, and that node data has a reference which is pointing to the next node too, and further it makes a proper list. And when a reference of the last node 3, you can see, is referred to null, that means the end of the list. This is what the type of the linear linked list structure. Now, but when we say about the circular linked list, every node points to its next node in the sequence like the former one, but the last node points to the first node in the list. This is how it is different from the linear linked list. So you can see there is no such null reference is in this type of data structure. That means your start and your end is the same. So that's how it is back to your first node. There is no end of this list. So in circular linked list, there can be no starting or ending node. The whole list can be traversed. Traverse means here scanning or access every node from any node. In order to scan or traverse the circular linked list only once, we need to traverse entire list until the starting node is not traversed again. So this is how we can scan the list and perform the circular linked list. Now let's see an example and an implementation. With reference to the implementation of circular linked list in Java, what we can do here, we can have a class, and that class has a subclass called a node, and this node basically refers to an individual node. So we can create an object of this class and maintain some methods, and those methods will definitely redefine and recall every time when we create a node in the main method. Now here, as we know, the node has two parts, one is reference and one is data. So based on that, we are just going to get the values from the user. So we have to implement the getter and setter for this node. Now this way is the most efficient way to implement circular linked list, because here what we can have, we can reuse this piece of code every time when we create a node. Now when it comes to the circular linked list main method, all we need to just have to perform the operation like insertion or display or deletion of any node. For insertion and deletion, the node, all you need to just make an option, choices and menu for the user and get the values from the user and insert it in the list. Now let's take a look at the demonstration, how it is going to be. When we see the circular linked list demo, all we need to have a class, and we are going to perform these operations like insert at beginning, delete at position or at the beginning, check empty if it is empty, size of a circular linked list, and display of list after every execution. So as you can see, this is going to be the output of this demonstration. Now let's take a look at the implementation. So this is my Eclipse IDE. First thing first, we need to create a Java project. All we need to have a name for circular linked list demo is my Java project name. Source, the most efficient way to create a maintain the coding standard is always having a package. This will make your structured code. So here I'm going to make the package name as linked list demo. Now inside this package, I can create my classes. So my first class for circular linked list demo is circular linked list demo. I need a main method, so I can just get it. Now, very first thing what I need to have is my node class. And before that, I just need to import my scanner, java.util.scanner class, so that when I ask the user to enter the value, it can be scanned. Now class node, my first thing is we need to create your node class, and inside the node class we need to have the data and the link, basically the reference, and that will be defined as a protected node link. So I just rename it as a link. Now first thing, we need to have the constructor. The constructor will help to reuse the piece of code, and whenever we ask for the initialization or declaration, that will help you to create it while creating an object. So for link and the data is already defined. Now let's have an overrided constructor. That's your node, but this time it will be your different signature, and this will help you to maintain and create an operation, perform an operation in your list. So suppose we need to initialize and get the value from the user and assign it. In that case, we use this type of constructor. Now the node is created, we have the link, initialize it, declaration is done. Next, we need to get and set the values from the user. Now for that, all we need to have the public void set link or get link data method. So for that, the argument is going to be as a node, because the node is going to be defined and get the values for the user. So this is set link. So for set link, we need to have the link variable assigned to some variable node. Just like that, we need to have the get link, but for get link, we need to have the return type of node. Get link, and here we have to return the link. Now once this set link and get link done, similarly we have to do it for data. So all we need to copy and make it for data. Instead, data, we need to have some data value like this, and similarly for get link, get data, and here return type will be your data instead of node, like this. So your getter and setter is done, the node is creation is done. Now next step is what we need to do, implementation of your method. So for that, we need to create a new inner class. Is just for linked list. Protected. So initialization of your list is going to be done like this. Protected, node start and node end. Since in case of circular linked list, the end, there is no end, but we need to mention the start is equals to null and start is equals to end for circular definition, circular type of pattern. And we need to have a constructor, and for that we need to define start, end, initialization is done, and size will be your 0. Now once this is done, the next step is first we need to check for the list if it is empty or not. So for that, if return is equals to start equals to null, that means your list is empty. So this will return accordingly. Public. Next is get size. For size, all we need to return the size. So this will traverse the entire list and accumulate and count the pointer and count the number of nodes, and based on that we can simply return the size of the list. Now next is insertion. Insertion of a node at the start. For initialization, just to start the operation in your list, let's have insert at start method. This will have a return type of your int val. The user will enter the value. That value has to insert. Now first thing we need to have the node pointer equals your new node which has the value, and since the start pointer is already null because it's going to add it in the first start pointer, so we need to have a reference of start, a link to the next, so that will be start. So once this is done, next step will be your if start is equals to null. So that will ensure that insertion of a node will be assigned if it is at the start reference or header, you can say. Since it's a circular, so it is not need to mention it. There is no end, so we need to mention end is equals to start. Now what if in case if it is not null, what will happen? So in that case you need to have the else block, and inside the else block you need to mention the end is set your link, sent link, and the pointer will be your, for end start set link is node pointer. So once this is done, then your start pointer will actually assign to node pointer. Now once this is done, we need to return the size of the list. So this will help you to implement your insert a node in a circular list at start position. Now what if in case we need to delete at some position? So for that, what we need to do is have a method delete at position, which will have the argument of position, which user will enter it, and here the first thing we need to compare, the size has to be more than 0 because that means the list has some nodes and it is at the position. Now what if in case it is at the position first? Start equals null, because if it is a start position, Since we have to make sure that position is supposed to be at specific position, not in the empty list, so we need to make sure all the conditions. Return, that's it. Now if in case position is equals to 1, that means your position first. So in that case, start will equals to start dot get link. We need to get the link, and it will assign automatically there. End dot set link, and that will be your start position. I mean, it is rewriting your position from current position what the user gave, and that will be at the start, and the size will decrease to 1 since it is already deleted at that position. Now once this is done, the next is at the specific position. So we have checked for the beginning and at the first position, for the empty position, empty situation, and for the first position. Now next we need to see for the specific position, which is supposed to be equals to size. Now once this is done, node has to be assigned again, and node t equals to position, so that is also start. So what we are doing here, we have to have two different object of node, because it is in case here we are rewriting and reassigning a deletion of the node at the specific position. So we have to reassign and swap the object. Get the link and assign it to the temporary assigned node. Now once this is done, we need to initialize your end again back to the temporary one, and end will get the and set the link. So what we are doing, we are simply deleting, decreasing the size of the list, and parallelly we have to reset the link. Now once this is done, next is all we need to just check for the node pointer. The node pointer will help you to assign it for the start, and the position will be your POS -1. The position will be decreased to 1. And for int, this loop will further traverse the entire list from 1 to the size, as you can see, and I plus plus, and this loop, if your I is equals to position, the node tmp equals to pointer dot get link. So what will happen? The temporary node pointer will get the link from the user and reset it at that position. So in that case, that positioned node was reset here in that case, and your temporary node will be your current node now. The particular node is deleted. Pointer will be reassigned to the latest current get link. And now once this is done, we have to decrease the size of the list since it is deleted. Now next operation we need to perform is your display the list. So all you need to scan the entire list. For that, let's have a method implementation of display the list. So all we need to have the node pointer start with the variable start, and if size equals to 0, that means your list is empty. So we can print the list is empty list and return to the main. Now if in case start is getting the link from the user and it is checking for the start, now in that case you need to get the value from the list. So for that, start pointer will get the data and plus, just for the reference, pointer will get the value of data. Start and then data. And then just to make it more structured, output we'll have /n. And then back to main method. Now once this is done, this will read the list for 2 position. Now for next, start dot get data and check for the pointer and the reference. We need to have the link for the node. So once this is done, next we need to read it until it will get the start pointer. Since it's a circular, so we don't have any null pointer or null reference to maintain the end and the last node of a circular list. So for in that case, what we need to make sure, that's what the difference from the linear and the circular, we need to have the start reference. So all we need to have the while loop which will read till the start pointer will come again. Pointer, get the data and just printing your next node. Pointer equals to pointer, that will get the link from the user from the list. Now this will go on until the while loop is true, the condition is true. Now once this is done, next get link and then print the data. Pointer dot get data /n. So this will have all the method implementation done. Now next step, we need to have the main method. First thing first, we need to have the scanner so that we can just get an object from the get the value from the user with the help of this object. First, we need to have the choice from the user. So for that, we need to have a variable, character variable. So in such cases, when we have any options for the user to perform some operation, we prefer to use switch cases. For such cases, we prefer the most efficient way to present it, the list or the menus. We recommend to have a do-while loop, because in case of do-while loop, this will first perform the condition and then check, first perform the logic and then perform the condition, then check the condition. So every time when we run, we can have a choice to enter. So that's why let's make it in a do-while loop. So inside the do-while loop, we are going to ask user to enter the choice. So insertion at the beginning, first choice, second choice, deletion at the position, at the specific position, and display or check the size, check the empty and return the size, right? Check for empty list and return the size, get the size of the list. So this will be your option, and again we can enter your choice, please, just for making it more interactive from the user. Enter your choice. Now once this is done, the next step is your int choice variable to get it from the user. Next int, and the switch will check for the choice. So this choice is basically your from this options and for the switch, and that will have the cases. Here we can have the implementation, the main implementation. Enter. So in case if user enter first choice, that means insertion at the beginning. Here we can ask user to enter the element for the node, element to insert. Okay, and once the user has entered, we need to create a list object. We forgot to define the link. So we have the linked list class, right? So we have to create a linked list object. So inside this class we have all the methods, right? So we need to have the insert at start, and the value will be the user enter the scan, right? So scan. Next. Okay, so what we can do, we just get the value from the user and put it inside as an argument, and once this is done, that will break and goes to the main method. This will break this case. Now just like this, we need to have for the case 2, and for case 2 we are going to have the deletion at position. So for deletion at specific position, what we need to do is ask user for the enter the position where the position of a node which need to delete it, right? So enter the position of a node that need to be deleted, right? So all you need to get the position, and once this is done, we need to have a variable assigned, and that variable will further check for the position to make sure that the list is not empty, and other condition the p is greater than list what we have the get size. And once this is done, we'll return invalid position and /n, else list delete at position. Just call that method and return the put the argument as the value user entered, and return. Break will take your controls to the main menu. Now case 3 is your check for the empty list. For checking the empty list, if we can just call with our empty status, in case if we didn't have, then in that case is empty boolean. Here you go. So this will return your status and break. Case 4 is your get the size. So you don't have to do anything because that already we have the size of the list. This the switch cases are done, or we need to have the default in case the user enters something different choice than mentioned. So invalid choice. And once this is done, we can ask user in case if he wanted to, and of course the displaying the list every time we execute it, so that we make sure that the list status is like this. And we ask user every time if he wanted to continue with the app. Yes or no. Type yes or no. So yes or no is like Y and N. So this will be easy to. So this will be basically for your choice Boolean value. So scan a character variable we have defined in the beginning. Next dot character, it's 0 since it is going to be a character Y or N, and we make sure that it is lowercase and uppercase. So for that we can have the while loop. We mentioned the while loop, no? Okay, while ch equals to capital Y, or ch, your character variable is lowercase y. So in any case, if it is true, then this will. So this is my implementation of circular linked list for insertion and deletion, and displaying the list with getting the size of the list. Now let's take a look at the execution. Before that, let's fix the errors. So it's insertion at the beginning. Let's insert my element. So this is the list displaying. I wanted to continue yes, and I wanted to insert one more time, and this time I'm inserting 7. So we inserted 7, and since it's a circular linked list, so it's making a list like this. Suppose I said yes, I wanted to continue. Insertion again, and I wanted to insert 9. So 9, 7, 3. So it's inserting at the beginning. Insertion at the beginning. Do you want to continue? Check for the empty list. So it is false, it is not empty. Now wanted to see the size of the list. The size of the list is 3, as you can see. Now since it's a circular linked list, so it's showing like 973 and the 9. It's back to the 9, the first node. So it's showing with the references. Now suppose I wanted to continue yes, and this time I wanted to do the deletion at the specific position. So in case if I wanted to delete the second position node, so it is deleted 7. Now check the size. It's 2, 9 and 3. So this is the execution and live implementation of circular linked list using Java. Now we have seen the demonstration of circular linked list. Let's take a look at some important facts about circular linked list, the advantages. Entire list can be read from any node of the linked list. Circular lists are the required data structure when we want a list to be accessed in a circle or a loop form. Address references to previous node can easily be found, which is not possible in single linked list. The best example to understand the circular linked list is like a giant wheel. Whenever we want a person to get down from their seat in a giant wheel, we need to rotate the entire wheel. Disadvantages: complex as compared to singly linked list. Reversing of a circular list is a complex as compared to singly or doubly list. If not traversed carefully, then we could end up in an infinite loop. So we make sure we are not making such conditions which will make it infinite loop. Like singly or doubly list, circular linked list also doesn't support direct accessing of elements. You need to scan to access a particular node, just like a giant wheel. Important facts. Circular linked lists are used in applications where the entire list is accessed one by one in a loop. Example, operating system may use it to switch between various running applications in a circular loop. It is also used by operating system to share time for different users, generally use round-robin time-sharing mechanism. Multiplayer games use a circular list to swap between players in a loop. Implementation of advanced data structure like Fibonacci heap. So these are the places where we generally use your circular linked list data structure. Now let's have a practice project as a homework for hands-on experience on circular linked list. So we have seen the demonstration of circular linked list for insertion element at the beginning, deletion at the position, check empty, and the size of circular linked list. Now, to have more execution and the better understanding of circular linked list, all you need to see the insertion element at end, insertion at position, and display the list after every execution. To understand it more, let's take a look how it will be your execution. This is your insertion at end, insertion at position. We have done the insertion at the beginning. So we can have more stuff added in this, like insertion at end and insertion at specific position. So for that, you can see here, this is what we have done already. So this is nothing new. Yes. Now, how about if you wanted to add it at specific position? Position is first. So the list is added again. Yes. And at the position or at the end. So 242. Now, yes. And we need to insert again the beginning 9. So this is what the list now. You can see at the end, at the position, these two features you can add and work on it. So this will help you to understand the basic concept of circular linked list in detail with examples and implementation. Thank you so much for watching this video. Please subscribe to our channel and contact techcrunch2019@gmail.com for any kind of questions, assistance and code. Let's make coding fun. Thank you.